Hello everyone, and I hope you're good today. My name is Tutor Monosi, and I'm both a smart tutor and a chemistry tutor at SkulChat. So in today's video, we will be talking about atoms, elements and compounds, and we'll also touch a bit on mixtures. So basically we'll be doing the classification of matter. So without any further ado, let's get into this video. Starting with an atom. If you can recall from the previous lesson, we learned that atoms are the fundamental units of matter. We learned that everything and anything that has mass and occupies volume is made up of these smaller particles or building blocks known as atoms. So in today's lesson, we will learn in more depth about atoms as well as the atomic structure. So even though an atom is the smallest particle of matter, it is made up of even more smaller particles known as the subatomic particles, and these include the protons, the neutrons and the electrons. The protons are positively charged, the neutrons are neutral, they have no charge, and the electrons are negatively charged. So getting into the atomic structure, an atom has an innermost core called the nucleus. This nucleus of an atom is surrounded by shells. So these shells surrounding the nucleus of an atom contain one type of particles, which are the electrons. And the electrons, remember, are negatively charged. And the nucleus is made up of two types of particles. The first type is called the protons, which are positively charged. And the second type are neutrons, which are neutral, they have no charge. So because of this, the nucleus has an overall positive charge. But all atoms have no overall charge. This is because in every atom there is an equal number of protons and electrons. So remember, these two have opposite charges. Protons are positively charged and electrons are negatively charged. So because they are equal in every atom, they result in a zero charge. As I have just mentioned, that the nucleus is made up of protons and neutrons. So the sum of these two types of particles gives us what is called a mass number. So the mass number is basically the number of protons plus the number of neutrons in the nucleus of an atom. This implies that the number of neutrons will be equal to the mass number of an atom minus the atomic number of the same atom. I hope this is clear. And the number of protons in every atom is called the atomic number. So these two kinds of numbers, the mass number and the atomic number, will be important when you talk about the periodic table, because elements or atoms in a periodic table are arranged in order of their increasing atomic number, which is the number of protons of each atom. So from the periodic table, we have the atomic symbol and the atomic mass and then the atomic number, but we'll talk about this when we get to the lesson of the periodic table. Let's move forward. Now let's dive into classification of matter. Assuming that you have a substance and you would like to know under which type of matter does your substance fall. So the first question that you're going to ask yourself is, can this substance of mine be physically separated? If the answer you get is a no, then your substance is a pure substance. But if the answer you get is a yes, then your substance is a mixture. So basically, a pure substance is a substance that cannot be physically separated, whereas a mixture is just a physical combination of two or more substances. Therefore, this combination can physically be separated, right? So let's continue. Assuming that this substance of yours now was found to be a pure substance, so we want to go on and know which specific type does it fall under? So you're going to continue and ask yourself another question. Can this pure substance of mine be chemically broken down into smaller pieces or substances? So if the answer you get is a no, then your pure substance is an element. But if the answer you get is a yes, then your pure substance is a compound. So basically, an element is a pure substance that cannot be broken down by any chemical means into smaller pieces or smaller substances. Whereas a compound is a chemical combination of two or more pure substances. So this combination can only be broken down by chemical means, right? Let's move to the other side. Assuming that your substance was basically a mixture and not a pure substance. So you'll continue and ask yourself this question: are the parts of this substance of mine or this mixture that I'm having hard to tell apart? Like, can I distinguish between or see the specific parts that make up my mixture or my substance? If the answer is a yes, then you have a homogeneous mixture. But if your answer is a no, then you have a heterogeneous mixture. So we basically have two types of mixtures: the homogeneous mixture and the heterogeneous mixture. The homogeneous mixture is basically a uniform composition mixture. You can't distinguish or spot the different parts of the mixture, whereas the heterogeneous mixture is not uniform. You can see the parts that make up the mixture. So the example of the homogeneous mixture, we have the solutions, and examples of the heterogeneous mixtures, we have the suspensions and the colloids, as you can see. Now let's continue and talk about this in more depth. As you have just noticed from the classification hierarchy, pure substances will either split into elements or compounds. So we are going to distinguish between elements and compounds. An element is the simplest form of matter. This is because an element is made up of a single type of atom. By definition, an element is a substance that cannot be separated or broken down into simpler substances by any chemical means. So elements are building blocks of other substances. And under elements, we have atoms and molecules or diatomic molecules. These are molecules that are made up of a single type of atom. So examples are oxygen, hydrogen, nitrogen, fluorine, and you'll find all these examples from the periodic table. Now moving on to the compounds. By definition, a compound is a chemical combination of two or more elements. It is a substance that can be separated into simpler substances by any chemical means, not by physical means. So under compounds, we have molecules as well as ions, and examples includes H2O, which is water. We have table salt, which is NaCl, and many more. So we'll talk about molecules and ions in upcoming lessons. We also saw from the classification hierarchy that a mixture too will split into either a heterogeneous mixture or a homogeneous mixture. So we are going to distinguish between the two types of mixtures, but we will first start by defining the term mixture. So a mixture is just the physical blend of two or more substances, and this physical blend or combination can be separated by any physical means. So what is a heterogeneous mixture? A heterogeneous mixture is a type of mixture which does not have a uniform composition, meaning we can be able to distinguish the separate components of our mixture. On the other hand, a homogeneous mixture does have a uniform composition, meaning we cannot be able to see each separate component of our mixture. So we said that the example of the heterogeneous mixtures include the colloids and the suspensions, and the examples of homogeneous mixtures include the solutions. So there are several separation techniques that are used to separate our mixtures depending on the type of mixture we have. Examples include distillation, it could be fractional or simple. We have filtration, we have chromatography, and many more. So we'll learn about those in our upcoming lessons. So guys, this marks the end of our second lesson in chemistry, which is the classification of matter. Thank you so much for watching, and I hope everything was made clear. So if you found this lesson helpful, please like our video, share the video, and also follow us on all our social media platforms. The name is SkulChat. Once again, my name is Tutor Monosi. I'm both a smart tutor and a chemistry tutor at SkulChat. So I'm signing out. See you in our next lesson.